All right, so when you took the notes last night, I started talking about differential equations. And what were some of the things that you guys noticed about differential equations?
You use the derivative or the y prime in the equation.
Yeah, so for differential equations, and you don't have to start new notes for this, we're just continuing the notes that you had. Things that we noticed about differential equations is that you have y prime in the equation. So y prime is not isolated necessarily. It's like within the equation. Okay. You're also going to notice that it's in the equation with x's and y's. All right. What's another thing we learned about differential equations from the video last night?
We still have a c or a constant value.
Yeah, we can still have constants. Okay. Did we learn anything about orders of differential equations? Yeah, what did we say about orders of differential equations? Yeah, it's what type of derivative. The nice thing about Calc AB is that we focus on first order differential equations, which means we're only working for the most part with the first derivative. We're not working with the crazier stuff. Okay. The other thing that we know about differential equations, which may or may not have like sunk into your brain last night, is that the solution to a differential equation is an entire function. It's not just a point. Okay. So the solution is a function, not a point. All right.
And that's why for number 4, when you asked us to find a particular solution, we had the function and the solution.
Yeah.
Okay.
Yep. And that's why when we found, a solution, we didn't have a point as the final solution. We had an actual equation with the c value is defined, right? Because it was a particular solution, not just a general solution. Yeah. So it wasn't like all the functions that fit this. It was that specific function fits that value.
Yeah.
Okay. All right. So for example number 5, we're going to verify that y equals c1 cos x plus c2 sine x is a solution to y double prime plus y equals 0. We're going to verify that c1 cos x plus c2 sine x is a solution for y double prime plus y equals 0. All right, so what should we do first?
Find the second derivative.
Yeah, and what do we have to do to find the second derivative? Find the first derivative. So my original function is c1 cos x plus c2 sine x. And so what's my first derivative?
C1.
Yeah, what's the derivative of cos though? Negative sine. So this is negative c1 sine x. And then what's the derivative of sine? Cos. Plus c2 cos x. All right, there's our first derivative. And then how do we find our second derivative?
Find the derivative of
Yeah, so this is negative sine, and the derivative of negative sine would be negative cos. So negative c1 cos x. And then what's the derivative of cos? Negative sine. So minus c2 sine x. Okay, so we have our second derivative. We have our differential equation. It's a second order differential equation because it has the second derivative in it. So we have the second derivative plus the function equals 0. And so what should we do now? plug it in. Yeah. So we know that y double prime plus y should equal 0. So I'm going to write down my y double prime, which is negative c1 cos x minus c2 sine x. And that plus the original function, which was c1 cos x plus c2 sine x, that should equal 0. So here's my second derivative, here's my function. All right. So when we look at this, what do we see?
Negative c1 cos x plus c1 cos x.
Right, so those would cancel.
And then negative c2 sine x plus sine x.
So we get 0 equals 0, which is true. So we verified it. All right, the next little thing we're going to add to our notes is about equilibrium solutions. So an equilibrium solution is where there is no change in the function. It is where the derivative equals 0. And it is where we will see horizontal asymptotes. I think to a point this unit feels a little bit abstract. And sometimes what happens is when we first introduce something for this unit, it will feel confusing. And then after a couple days of working with it, it'll be like, oh, okay, that makes sense. So some of this stuff today may not make as much sense, but when we go back after, like throughout the unit and look back at these notes, it'll be like, yeah, I can see what you're talking about now, okay? So give yourself some time to absorb this. Don't necessarily feel like you have to have it perfectly right from the beginning, okay? So example 6, and this is the last of our notes. We're going to find the equilibrium solution for dy dx equals y squared minus y. All right, so for a lot of the differential equations we did, we were using y prime for our derivative. Sometimes they'll have dy dx, sometimes you'll have y prime. What I've noticed is typically if they have a differential equation where the derivative part of the equation is isolated, they tend to use dy dx, and then if it's not isolated, they tend to use y prime. That's kind of what I've noticed. There's not necessarily a right way and a wrong way. It just is different notation, just like we've done before. So this is another way of saying y prime equals y squared minus y. And if we're looking for an equilibrium solution, all we have to do is take this and set it equal to 0 and then solve for y. So I would say y squared minus y equals 0, and that's because this represents the derivative and the derivative equals 0. And then if I was to solve for y, what would I have to do?
Take out y.
Yeah, take out a GCF of y. So that would give me y times y minus 1. So y equals 0 and y equals 1. So this differential equation has two equilibrium solutions, one at y equals 0, one at y equals 1. Okay?
So if it asked us for this and then gave us a function, we would have to find the derivative of that function and then plug it in?
Yeah, and once we since this is an intro to the idea of equilibrium solutions, we're not going to do a whole lot with it yet. Later we start looking at differential equations specifically with logistic functions, and with equilibrium solutions it's always like, oh yep, I just factor it and those are my equilibrium solutions. They get to the point where they're so easy to find they're kind of boring.
Yeah.
So it's the same idea. It's just like set that equal to 0, factor it, solve it, but now instead of saying they're x-intercepts, we're talking about differential equations, so we're like, oh, that's my equilibrium solution. All right. Okay. We feeling okay with that stuff? Okay. So we're going to go ahead and move on to our assignment, which is a matching worksheet. So I'm going to go ahead and hand this out. All right. So these problems are going to get easier as you go, because it's a matching assignment, so as you start to narrow it down, the assignment's going to get easier, okay? So if we look at problem number 1, we have all these different differential equations. We're trying to see which one it's a solution to. So if you notice, some of the differential equations only have the first derivative, some of them only have the second derivative, some of them have the first and the second derivative, okay? And as you go through the assignment, you'll start to pick up on like maybe some shortcuts or maybe some strategies that will help you define the other ones, okay? So first, what I'm going to go ahead and do for number 1 is I'm going to find the first derivative and the second derivative, just because that seems to happen for some of these problems, okay? So y prime for number 1 is what? Okay, so that's negative 2e to the negative 2x. That's the first derivative. The second derivative is what? 4e to the negative 2x. So that's if we kept this the same and then multiplied by the derivative of the exponent. Okay, so now we have to think through which one this could fit into. Okay, so this first one is saying if I do the derivative minus 2 times x times y, it's going to equal 0. All right, so the derivative minus 2 times x, when they say y, they're talking about the function. So if I do the derivative, which is negative 2e to the negative 2x, and subtract off negative 2 times x times e to the negative 2x, are those going to cancel out to be 0? No, so it's not a. If I take the derivative, which is negative 2e to the negative 2x, and I add 2 times the original function, are those going to cancel out to equal 0? Yes. So this one is negative 2e to the negative 2x plus 2 times e to the negative 2x equals 0, which is true, and so number 1 is B. All right. Do you see how there's some maybe strategy involved with this? Okay. You're going to start to notice like, oh, that one's got a 2 in it, so this one should have a 2 in it, things like that. Okay. So go ahead and just get started working on that. The assignment is written on the wall. It has some problems from the Stewart page in the textbook. If you flip this over, I scanned the Stewart page for you. There you go. Okay. All right. So your whole assignment is just from this front and back. Okay.